Alrighty, this is section 9.1. We're talking about solid figures. So first, what is a solid? A solid is simply a 3D or three-dimensional shape. Next, what is a polyhedron? A polyhedron is a solid that only has flat sides. So for example, you could think of a six-sided dice. A dice has only flat sides, so it would be a polyhedron. Next, we have a face. A face is just one side of a solid, so think of one of the sides of your six-sided dice. Next, what is an edge? An edge is the line connecting two faces, and the vertex is the point connecting two edges. Think of this as a corner. So to the right, I have an example of a lot of these solids that we're going to be dealing with in a picture, so we can use that as we're moving on today. So, example 1 asks to tell whether the solid is a polyhedron and describe the shape of the base and name the solid. So first A, is this a polyhedron? Well, I'm just going to ask, are all the sides flat? To me, all the sides are flat. I don't have any curved sides, so yes, this is a polyhedron. Next, describe the shape of the base. So the base, or the bottom, here is a triangle. And last, name the solid. So looking at our chart up at the top, if I have a base that is a triangle, and I also have a triangle on top, and those two triangles are connected, this would be a triangular prism. Let's look at shape B. Is this a polyhedron? Well, I have curved sides, so this is not a polyhedron. What shape are my bases? Well, my bases, on the bottom, we have a circle, so the base is a circle. So looking up at my chart to name this solid, well, I have the top is a circle and the bottom is a circle, so this is a cylinder. Alrighty, let's go down to example 2. Using the diagram at the left, first we must name the polyhedron. Well, here it looks like I have a square as my base, and then from each corner of the square there's an edge going up and meeting at one point. So looking up at our chart, this would be a rectangular pyramid. Next, we need to count the number of faces and edges. So for faces, I have one face or base on the bottom, and then I have 4 triangles around the top, so I have a total of 5 faces. And edges, on the bottom, I have 4 edges, and then I have 4 edges that are all pointing towards the top, so I have a total of 8 edges. Next, we must list any congruent faces and edges. Well, I have only one square face here on the bottom, but I have 4 triangular faces pointing up to the top, and each one, according to the tick marks, all have the same length of sides, so all our triangle faces must be congruent. So I can write a congruency statement for this. So I have triangle ABE is congruent to triangle BCE, which is congruent to CDE and congruent to DAE. All those triangular faces are congruent. Next, let's look at the edges. Well, like I said, those 4 lines all pointing at the top are congruent. So I have that AE, BE, CE, and DE are all congruent. And I also see that the 4 edges along the base are congruent, each of these 4 sides. So I have AB is congruent to BC, congruent to CD, and congruent to DA. So we have all of our congruent faces and edges. Alrighty, so last you have 3 checkpoints, numbers 1 through 3, to complete for tomorrow.